So today we're going to be finding the Maclaurin series for the following function: x to the 4th power, ln 1 plus 3x to the 7th power. We're going to be, first place I want to start with this one is the representation of this function. So this function is actually the one that you're probably going to be a little more familiar with, so I like to use that one to start out. So that's going to be this function right here. And we know that this representation is going to be the power series from 0 to infinity for x to the n. Now, the next step that we're going to take is we need to put in a subtraction symbol inside the ratio. Like you remember that if you have a geometric series, that's technically kind of what we're using for this one. So in fact, we're going to have to manipulate that by doing a minus minus, and it's common to put parentheses there just in case you have anything else, which we will in this example, because you are to the 7th power and the 3 there. But I digress. That means you're going to put a negative x in here, right? This should be your second step. Now, the next step is we need to integrate this function. Now, guys, when you're integrating this, you can integrate inside of the actual expression. They don't really go over that, but that's going to mean that you do have to follow the chain rule for this inner expression. So we're going to have a -1 there. You'll be left with what's inside, of course, your original function here, and then n plus 1 goes down here, right? So that's going to be so far what we have. Now, I prefer doing it this way. So far we have this, but we haven't accounted for the 3x to the 7th or the x to the 4th. I like to leave this part for last because it's just a multiplier. So far, this is what we have. If we're going to do 3x7, let's go ahead and simplify what we have here in this example. So just use this over here. When you integrate, you don't have to shift the index. Most of y'all probably don't know that you can do that yet until you hit DPQ, differential equations, anyway. But yeah, when you're integrating, just for the record, no shift required. I'm going to put this again. So I'm rewriting and trying to keep everything as separated as I can. So let's go ahead and do this. And I'm going to go ahead and put in, I'm going to take out that -1 there, right, to the n plus 1 in our expression. After all, we can just take that out, actually. I'm going to do that. We're going to be left with negative. And then I'm going to go ahead, since we took that negative out, sorry, we're going to put 3x to the 7 here to the n plus 1 power. Okay, so far so good. We still need an n plus 1 down here. So 3 to the n plus 1, I'm going to take that out there. And then I'm going to have this x to the 7n. Now, let's see, I'm going to have -1 to the n, 3n plus 1, and then we're going to have, now I'm going to use that law of exponents there to break that up. Now at this point, all I have to do is factor that x to the 4th power in. This is just so much easier. I find this method used for that noise. The last thing we're going to do in this is we're going to do a table. We're going to do a few values of n just to see what we've got here. I like to check my work oftentimes using Google. And really I'm just evaluating for each power of in here. If it's 0, negative 1 to the 0, the series terms in here. 3, 0, plus 1, 0, plus 1, and then we'll have 7 times 0 plus 11. It's all going to just be equal to 3, and then x to the 11th power. I like to integrate my functions when I'm doing these. It's just, you know, it's really, you need to know how to make sure you're doing that, know how to do that. So this here we have here, like I did in this example. Second power, x to the 14 plus 11, 2. Negative 9x, 14 and 11. Didn't I have... Is that to the 25th power? Something seems off. Oh, that's n equals 1. Yeah, that's what I thought. Sorry about that. That's not 14. There we go. 28. Or 18. Yeah. And then if you keep doing this, you will in fact have your... This is... for each term, of course, wherever you stop, that's where your sum is going to stop. So that's your, where n equals 0, that's your first term, n equals 1 is your second term. So also understand these are terms. And that's that. For the rest of my terms in this table, I'm just going to go ahead and utilize Mathematica. So 1 minute here. So if you continue on with your terms, you should be getting what I'm about to... So I want to make one thing clear. You are generating a sum, right? So whatever you stop at, whatever your max level is here, let's see. So instead of it being infinity, even though it isn't, you know, an infinite expression, the way we're doing the notation, of course we're gonna let that be a number that we want to stop at to some degree of accuracy. We're not doing error in this. But, you know, if you stopped out at your 5th term for n equals 4, which is the 5th term, by the way, because our first term was at 0, n equals 0, then if I went out 5 terms, I'd have to let this index out to 4, like you see in the table there. So just if we do the second power, then if I look at, or not the second power, but the second value, then the 3rd term, then I'm going to have to distribute this all out. It's going to be this last term over here with this. Again, this is generating a sum, so when you get out here, that next term is going to be this. That is actually going to be for n equals 2 there. So you're going to have plus 9, see, x to the, add these up, 25th. So then that would have been this term right here. And then so on. So then now this is your 4th term here, which is going to be this one. So negative 81 x to the 32 all over 4. And so I'm going to write all this out. And then our last term, that's going to be the 5th term here. And this is just arbitrary. I generated how many terms I wanted to go out. I mean, depending on who you have. If you got a nice professor, they might only have you go out to, you know, 3 terms. Let's see, over 5, and then x 35 it should be. So x to the 39 power. Right. Okay, so this is our series, guys. If I went out 5 terms for n equals 4, this is what we're going to get. Hope that helps.